Hello and welcome to this episode of Microchips. In this episode we will be looking at this Cybernet Beta 3000 CB radio that I got from eBay as a job lot of radios. I have no idea if it's working, but let's put it through its paces and see what it can do. So somebody's already resprayed the lid by the looks of it, but I'm going to take care of that. On a first look inside, somebody's soldered some power leads onto it, so we need to get rid of that. But all in all, looks like it's not been touched. Same with the bottom cabinet, somebody sprayed it. But inside, looks pretty good, looks pretty untouched. So the question is, does it work? So first things first, nice inspection of the board. Not sure what that's about. I think that's been done in the factory. What's drawn my eyes to this is that there seems to be some dry joints or some cold solder joints on the RF output transistor. Not sure whether it'll cause any problems, but we'll solder it up and then it definitely won't cause any problems. So power on, looks good, seems to work. Doesn't seem to be any missing segments on the display. Let's do some transmission tests. It's a little bit low on frequency. Maybe that's an aging crystal, or maybe it just needs a good alignment. But it seems to be mostly okay. 1, 2, 1, 2. Now, as I was doing an audio test, I noticed this crackling noise along with the carrier. So I changed the microphone over, thinking it was a dodgy microphone. And we still have this noise on the carrier. Don't know if it's coming across on the video, but it was actually quite noisy. So I wonder what that could be. So just doing a receive test using my signal generator. Not sure where the LED lights are supposed to be on this, but minus 70 dB should be a +9. So we'll just set it just on the edge of that. We'll bring the signal down. Yep, seems to be receiving just fine. So let's try channel 40. Yep, all checks out good. Now I need to investigate this noise. So I've noticed whilst pushing and tapping around on the board, we can get this noise to change. So we've got a dodgy capacitor. I am transmitting at this time, and the noise you can hear is the noise coming from the radio. You can hear it crackling and so let's try on the back of the board. And then we've got a massive crackle from that area. And I think we've found our problem. We have another cold solder joint or dry joint. Seems to be getting quite common with this radio. So let's solder it up. Just do a couple more suspicious cold joints around the place. Hopefully that's our problem fixed. And sure enough, a lovely quiet carrier. Problem solved. So let's have a play with this radio. So first off, front comes off. You have to desolder the microphone socket and the capacitors that go on the back of it, which is not a nice job. And we are going to fit midband to this radio. So first off, we need to take a couple of components out. And to get the PLL chip out, we actually have to unscrew the front and tilt it out of the way. And out comes that very big 7136. I'm just doing a test fit of the board to see whether it actually fits underneath the channel change, which it just about does. And there's our board made up, with the PLL soldered in, the PIC chip soldered in, and all the connecting wires ready. So from past experience with these boards, we need to replace C1, which is connected to the crystal, from a 56 picofarad to a 22 picofarad. This will increase the frequency, but we need this because when we fit our frequency compensation board, the frequency will lower and hopefully drop us right onto frequency. So it's a little bit fiddly to get this modification board in due to the channel change being in the way. We've changed C1 now because it sits right next to the pin header that we're putting in and can be difficult to get out after. So there's our pin header soldered in and the two components moved to the back of the board. We move these components to the back of the board so the pin header will fit into place. One's only a choke from the supply line to the PLL. And a couple more suspect dry joints as well. Okay, let's do a test. So the light's on, VCO's locked. So connect the transmit wires. As you can see, the frequency is high, which is fine, because when we fit our board, this will actually come down. So that's good, working as expected on UK40. So let's try midband. VCO's locked on channel 40. Frequency is high, which is to be expected, but we're going to fit something to bring that down anyway. And channel 1, the light has gone out, VCO's unlocked, so we need to broadband the VCO. But we'll just try and lock it first. There we go, right on the edge. Now I found if you don't broadband the VCO, it sits right on the edge, on the extremities. So we'll just connect the wires for UKFM. And we're still locked, but we're going to broadband it anyway, gives us a little bit more scope. And this is the capacitor which we will be removing. This is actually C23. We will be changing that from a 33 picofarad down to a 22 picofarad. This is more than enough to give the VCO a little bit more range. Solder it into place, and another dry joint. So let's check the VCO voltage across the bands. As long as our light is on, we're locked, but we just need to make sure that it's even across all the bands. Now the frequency counter's a little bit unstable on channel 1 mid. This is because the power output is practically zero. But I know it's working. So that's our modification in place. We just need to connect up a suitable switch now. So we're going to be using the PA switch. Now another reason for removing the front off this was to get this switch bank out. And look what we've found, yet another dry joint. This one seems to be on the clear switch. So I'm just checking which way the switch goes round, and as suspected, we've got a centre common. So firstly we need to disable the PA, and to do that we need to connect this red wire to the two yellow wires, and also the PA LED is on this pink wire, which we will be using, and those two yellow wires go to the front switches anyway, so it makes it easy wiring. So we've got the PA LED wired up, with the help of a little jump wire, and we need this supply as well for our frequency compensation board. So that leaves us one side of the switch free, which is perfect for our UKFM and midband switch. So now let's test it. So channel 40 UKFM, channel 1 UKFM, push the PA switch in, and we have midband. High on frequency, but fine. So that's a nice tidy modification for that. So here's our frequency compensation board installed. Just need to connect the crystal wire. So basically this board is energized when we are on midband, and it switches in the variable capacitor. And I'm using a 8 to 50 picofarad variable capacitor. So when you actually connect that white wire, it does alter the frequency ever so slightly. As you can see, it's pulled it down to practically bang on UKFM. 6011 is close enough. Now channel 1 midbands, it needs to be sorted out, but that's a power issue. Due to the RF stages not being tuned up yet. But as you can see, the frequency is now dropped because we've added a variable capacitor in. So after a quick trim with the variable capacitor, we now have it bang on midband. So we'll place it in some heat shrink and tuck it away at the front of the radio, trying to keep that crystal wire as short as possible. And of course a good clean of the front panel with some foam cleaner. Now as you can see, the power output is very low on channel 1 on midband, so that's easily brought up by using the Rotel service manual. Tells us which coils we need to bring up, which is T4, T3 and T2. And we're just going to try and get it uniform across the bands. I know we're not going to be able to get it perfect, but we can get it close to. So we're just a bit low on UKFM channel 40. So we'll adjust that again ever so slightly, and that should be enough. Ranging from about 4.5 watts to 5 watts across the bands. I think that's good enough. Now the receiver alignment, we've got our multimeter on test point 2, and as per the service manual we just need to adjust some coils and just bring the receive up. Nothing much to see with the receiver alignment. So here we have it. So channel 1 UKFM pretty much on frequency, channel 40 UKFM pretty much on frequency. We press the PA light comes on, goes on to midband, bang on frequency. All in all, happy with that. Quite an in-depth modification for this. But if you spend the time on it, it makes it look good, and it's actually proper now connected to the switch. It's bang on frequency, and we have a uniform power output across the bands. So there we have it, our Cybernet Beta 3000 with a fault repaired and midband fitted. All in all, quite a challenging modification, but happy with that. But anyway, thanks for watching. Don't forget to like, subscribe, join my Patreon, join my Facebook group, and we'll see you in the next video.